got a 2008 E60 M5 in, 87,000 miles on the clock. Come in for preventative maintenance. Very sensible customer has heard that the Comrod bearing shells can prematurely wear. He hasn't got any knocking noise or any problems. He's just having them done as preventative maintenance. So this is the documentary. We don't know yet what we're going to find. We're just going to start the repair now and then show you our findings. Front suspension's disconnected and cross member taken off, and now the sump's been removed and we've got access to the bottom of the Comrod bolts, so we can start turning the engine over and checking the clearances on these old shells first. We're also taking the opportunity to change the high pressure Vanos pipe. The internal one, which is inside the engine block, is not showing any signs of leakage on this one, but they can do on these V10S 85 engines, and it's around about £100 for the new part from BMW, and the only way to get to it is have the sump off, and that's what we've obviously got off for the Comrod bearing, so it's a perfect time to do that. So a few things out of the way in the engine bay to access the exit point for the valve, the hose, which is that hole there in the engine block, and at the other end we'll feed that down and connect it onto the Vanos high pressure pump at the bottom of the engine block. I'm underneath the car now and Luke's feeding the new Vanos high pressure pipe into place. So here it is, just exposed, and we've got the Vanos high pressure pump off out of the way. It meshes with that gear over there, and that's roughly in the correct location. It's a flexible braided hose, so once it's bolted at the top and banjo bolted down at the bottom, it will be clear of all of its internal components. But that's why it's important to change it at this stage, because it sits inside the engine in the timing case. You have no access to that until you take the sump off, and to get the sump off you've got all the front cross member from suspension work to take off. So for the sake of an extra probably an hour's work and £100 worth of part, it's worth doing at the stage whilst you're doing your Comrod bearing shells. Here's the old Vanos high pressure pipe, the one that was in there from original, and the old Comrod bearing shells, the uppers and the lowers, and the Comrod bearing bolts themselves. So cylinder 1 is up on the top left, cylinder 5, cylinder 6 through to cylinder 10. And clearances were very good, so sometimes visual appearances can be misleading, because to look at that, if you didn't really know what you were looking at, you would think, well, that's almost failed or very, very poor condition. Although it's gone through several layers and it's showing copper on there, which is a little bit of a marker of a wear, clearances were okay on these old shells. The worst, or the range that we found, was between 0.038 of a millimetre, and the largest was 0.063 of a millimetre, all those which are in range of BMW's tolerances. So it's mainly cylinder 1 and cylinder 10 uppers that were worn through several layers through to that sort of copper shiny material. And so we went with new BMW shells, the 702 and 703, current up to date 2016-2017 batch. These are the 088, 089 from a 2008 car, and we went for standard sizes, obviously, as most people are aware. There were no issues or damaging or scratches or anything picking up on the journal, so it was just a straightforward Comrod bearing shell replacement on this V10S 85. So it's really important all the clearances are checked on the old bolts, on the old bearings and the new bearings. You cannot really just guess and put them in, because you just never know if the gap was too large or the gap was too small. So BMW used a plastic gauge system to measure the clearances, and then we have a data sheet which we've prepared, which also gives us lots of the clearances up here. I'm not going to show it all, it's got customer specific information on it, but and then torque procedures and final torque angles, so that we know that every single bolt has had the correct 3-stage BMW torque process, and the clearances have been checked from old to new. This is the oil filter housing from the E60 M5 that we're doing Comrod bearing shells on, and you might be able to pick up copper sort of coloured metal flakes which are in the bottom of the oil filter housing and just sort of dribbling down. They might not actually be copper material, they might just be
all sorts of metal from the shells, bearing shells, but they've got that copper colour because of the engine oil, more than likely. There's a couple up in the top section. Hard to actually see when it's moving, but there are particles in that oil, and that's an indicator that there are something wearing, or could be starting to wear, with the conrod bearing shell. So if you do see that when you're doing an oil filter change, or your garage does, then it would be worth considering that as a repair option. Preventative maintenance is better than replacement. The car's back together now, torque checked and suspension fitted, and crankshaft sensors unplugged, which is that plug dangling down there. So we can go for the first start. We've got the CHF 11S power steering fluid topped up, new oil filter, and Castrol Edge 1060M power oil. So when we do our first start, we know that we're going to build oil pressure without starting the engine, so there's going to be no load on the conrod bearing shells for the first time. And we can turn it over now and build oil pressure. And then we'll keep doing this to make sure we've built oil pressure before we plug it back in and start for the first time. We've now plugged the crankshaft sensor back in and fitted the under tray, and the car started first time, and it's just levelled out off cold start. And now we're going to let it do its first heat cycle, warm the engine through in the workshop, and keep an eye on the top and the bottom and make sure there's no leaks and things like that, and listen out for noises. And then once we're happy that it's done a good heat cycle of over half an hour, then we'll take it out on road test. Just going through the heat cycle and about to update the oil level check. There's our oil level confirmation. We've done about 12 miles on road test and oil level is okay. And that pretty much completes the job. We've done static heat cycles, probably over an hour now, with no leaks, no faults. Checked again on a ramp and everything is all dry and clean underneath. Like I say, 12-mile road test, and that is a successful repair. That completes the end of the conrod bearing shell replacement. 12-mile road test, lots of heat cycles, running in instructions handed over to the customer, and that is another one done and ready to go on back home.